Hello everyone, good afternoon, and welcome to this town hall on the next generation of big data management and digitalization to support a sustainable blue economy. I'm Jake Sobin, I'm with Collinsworth Maritime Sensors and Robotics team, and I also sit on the MTS Council as the chair of the Washington, D.C. section. I'd like to start off first by thanking the local organizing committee. I know how hard it is to be on the local organizing committee, so thank you very much for supporting this session and putting on a great conference. So last year, during Oceans 21 in San Diego, I was the session chair for the panel discussion, The Role of Marine Robotics in Supporting a Sustainable Blue Economy, where we discussed the advancements in ocean data collection and analysis supported by marine robotics. The one common thread from that Q&A session was that with technology innovation moving so fast, more and more sensors and platforms are entering the maritime space, creating the challenge on how we manage the data. So that gave us the idea for today's town hall, focusing on big data management, and we have put together an excellent panel of experts to speak on the topic. So sit back, please enjoy this discussion, but please also write down your questions. We have budgeted 25 minutes at the end to take questions both in person and hopefully online. So if you're listening online, we will try to take your questions at the end. Now it is my honor to introduce the moderator for today's town hall, Mr. Joel Scott with NASA. Joel is a program scientist at NASA's headquarters in Washington, D.C. He's supporting the Ocean Biology and Biogeochemical program within the Earth Science Division of the Science Mission Directorate. Joe has formal training in satellite remote sensing of the Earth, ocean, and atmosphere, and has extensive experience in Earth system research, data science, and program building and management. Joel has focused his career on using Earth observation to study aquatic ecosystems, the carbon cycle, and the elements that support life on the planet, our home planet. So all of this makes him the perfect moderator for today's session. So Joel, I'm gonna go ahead and turn this show over to you.
Awesome. Thank you, Jake. It truly is my honor and privilege to be here today, and I'd like to thank Marine Technical Society and the IEEE Ocean Engineering Society, as well as the meeting co-chairs and the local host committee for bringing us together to have these important conversations. I'd also like to thank all of you here in the audience today and those joining us online. Thank you for being here. I'm looking forward to our discussion. We have an exciting set of panelists here, and we're going to cover some important topics, as Jake mentioned. So let's begin by setting some context on the blue economy. Humanity depends on ocean ecosystems and the functions that they perform from local to global scales. While fully quantifying the value of our ocean systems to humanity is a daunting task that some might even say is impossible, estimates based on the ocean's global annual gross marine product pertaining to marketed goods and services are at a staggering $2 trillion with a T, US dollars per year, with a total asset base of at least 20 trillion with a T still US dollars. Furthermore, aquatic ecosystems provide 20% of annual animal protein to over 3 billion with a B people each year, and this value exceeds 50% in some countries. The ocean also generates hundreds of millions of jobs in sectors spanning tourism, fishing, energy, shipping, and biotechnology, ranking the ocean as the 7th largest global economy. Over the past few decades, as Jake mentioned, marine technology has experienced an incredible innovation and multiple advances. We are seeing more autonomous systems that can collect higher frequency data on more rugged platforms that can collect this higher frequency data for longer periods of time and in more extreme conditions. We are collecting better resolved data with higher accuracy and more detailed measurements than ever before. And this is known as the arrival of big ocean data. And it could not be more timely, as we and the ocean are facing bigger challenges than ever before. From sea level rise and coastal subsidence, as we heard this morning, to marine heat waves and increasing ocean acidity. We are seeing larger and longer harmful algal bloom events accompanied by shifts in primary production with cascading impacts on the carbon cycle, and that are felt across every different trophic level, from microscopic bacteria to large fisheries. Climate change, along with other human impacts, such as nutrient and plastic pollution, threaten the very foundations of the marine food webs and placing whole ecosystems, as well as those of us who rely on them for food and jobs, at risk. The importance and sustainability of the blue economy cannot be minimized or ignored. During this town hall, our panelists will provide insights into emerging technologies and methods for addressing big data management and digitization efforts to support and grow a sustainable blue economy. Today, I am delighted to introduce our panelists. We're going to start with Colleen Peters, who is the bathymetry data manager at Saildrone Inc. Colleen is sitting next to me, and she has built her career on scientific data collection and data management, having worked at NOAA, the Schmidt Ocean Institute, and OceanX prior to joining Saildrone in 2021. Colleen has been a driving force behind the data management strategy at Saildrone for the collection and dissemination of data from their Surveyor and Voyager class uncrewed survey vehicles. Next, we have Karine Basson joining us, a data solutions architect for the Schmidt Ocean Institute. Karine has experience in both the private and public sectors, having worked at the University of Washington's Applied Physics Laboratory, where she has spent many hours on research vessels collecting oceanographic data. Karine also worked with NOAA Fisheries, where she led the development of the NOAA Fisheries Integrated Toolbox and encouraged the adoption of open source science within the federal government. Today, it is also my privilege to introduce you Mimi Lobaker. And Mimi and Karine switched seats on me, so I apologize for that. But Mimi is an expert in ocean mapping with 20 years of experience with acoustic multi-beam, sub-bottom, side scan, and split beam sounders. She has worked with the NOAA Office of Ocean Exploration and Research and with the University of New Hampshire's Center for Coastal and Ocean Mapping Joint Hydrographic Center. Mimi joined Kongsberg Maritime in 2022, where she oversees technical sales and ensures that the NOAA and UNOLS fleets are outfitted with advanced integrated acoustic systems. She also supports their Blue Insight initiative to help bring cloud and remote services to the blue economy. We're also joined today by Dan Pisou, a principal engineering lead at Esri. Dan has over 2 decades of experience with data visualization, working with NOAA to leverage data for research communications and outreach. He currently leads the development of Esri's online environmental content, including data products focused on Earth's land, ocean, atmosphere, and ecosystems, with a particular emphasis on data-informed approaches for community and coastal resilience. Rounding out our panel today, we have Catherine Weathers. We heard from her this morning. Catherine has experience in the public and private sectors, working in both realms to leverage remote and in situ Earth observations to better understand marine environment and its ecosystems. She joined NOAA's National Centers for Environmental Information, or NCEI, as an uncrewed systems data coordinator in 2021. And Catherine is also the current chair of the Gulf Coast section of the Marine Technology Society. Welcome to you all. Thank you for being here today. And let's move into opening remarks from our panelists. And Colleen, would you care to go first?
Scientific equipment all over the world and managing and collecting, visualizing all of the associated data. So now I've transitioned to uncrewed surface vehicles at Saildrone, and my specialty there is with seafloor mapping. So for those of you who are not familiar with Saildrone, we are based in Alameda, California. That is where all the magic happens. That's where we build, assemble, and test most of our platforms before they go out on missions. We also have a lot of in-house software development for the control of the vehicles, as well as our data pipelines and visualizations. And just this year, we opened 3 more offices in St. Petersburg, Florida, Washington, D.C., and Fall River, Massachusetts, where we have a passive acoustics group. We have 3 main business lines at Saildrone. Maritime domain awareness has to do with intelligence, surveillance, law enforcement, mostly government and military activities. Ocean data is really what Saildrone was founded on, so the ability to take essentially a shell of a platform, one of the 22-foot explorers, and customize the platform for the dedicated research. So the mission personnel will decide what sensors will go on that platform, how many platforms they want to use in a particular mission, whether that's for data redundancy or to explore a region more thoroughly. And then we have our newest business line, which is ocean mapping, which is the group, of course, that I work for. And this is where we are adding the capability to conduct a variety of different bathymetric surveys, primarily with multi-beam. Saildrone is operated all over the world, collecting data in all oceans, and this has been in a large part to do with the ocean data division. So a couple of our most notable missions have been the circumnavigation of Antarctica, and something you may have seen in the news recently is our hurricane mission, where we've captured not only data but also real-time footage of the inside of a hurricane at the sea surface. So this is a proven technology operated in all different kinds of conditions. These are our Explorer platforms, which are solar-powered and wind-propelled. Now we have the Surveyor, which is 72 feet and is solar-powered, but also has a diesel engine for extra power charging capability, because the multi-beam sonars require a lot more power draw than the sensors that are used otherwise for ocean and atmospheric measurements. The Surveyor is equipped with a variety of different sonar systems, but the highlights, of course, are our Kongsberg 2040 and 304 multi-beam sonars. So looking towards the future of Saildrone, and particularly in the ocean mapping sector, we have the Explorers, which I've mentioned, are our smallest platform at 22 feet and use single beam or wideband mini transducers to conduct more reconnaissance type of mapping. We have the Surveyor, which you just saw on the last slide, which has the shallow and deep water systems, which allows us to map from about 5 meters all the way down to 7,000 meters. The next generation Surveyor will have the Kongsberg EM304 Mark II, which will actually take us to full ocean depth. And then we're also introducing later, probably next year, the mid-size platform Voyager at 33 feet, which will have Norbit multi-beam, sub-bottom profiler, or ADCP, and is somewhat customizable for coastal ocean mapping. So with the fleet, we look forward to being able to cover sort of all of our bases in seafloor exploration. So thank you very much for having me, and I'll pass it over to Corrine.
Thank you, Colleen. And as mentioned, on to our next panelist, Corrine from Schmidt Ocean Institute, for her opening remarks.
Schmidt Ocean Institute, SOI for short. Schmidt Ocean Institute is a philanthropic foundation founded in 2009 by Eric and Wendy Schmidt, and works to advance the frontiers of global marine research by providing state-of-the-art operational, technological, and informational support to pioneering ocean science and technology development projects at sea. In 2021, SOI announced its strategic framework, available on our website, with the simple purpose: boldly explore our unknown ocean to excite interest and inform the wise stewardship of our planet. SOI makes their vessel, systems, and equipment available to researchers through a proposal process. All that is asked in exchange is that they make their data open. Open data sharing is a core principle for SOI because it enables the growth of data applications and increases the speed at which we obtain ocean knowledge. The faster we acquire and share data, the faster actions can be taken, as we recently saw during the COVID pandemic. SOI is working across sectors and communities to engage in solutions for the community in terms of advancing data accessibility. Some of our initiatives that we're working on for our internal data systems pipelines and data access, I think, are of interest to the community here as we look forward to a larger scale blue economy. Our data strategy includes all steps of the data pipeline. Before we can move into the future, we need to make sure that our foundations are solid. This doesn't mean just doing what we've always done, but looking to new solutions for old problems. So we are working towards solutions and steps to ensure better provenance, governance of our open data, and credit for those who share their data widely. We're also looking into ways to track information related to data creation and dissemination and use through a larger ecosystem of persistent identifiers that are currently being developed, so this is beyond DOIs, so that we can use PIDs to track not just how data is created, but the web of areas that it goes to. It's not a linear problem, and we need to make sure we understand that larger web. Richer, more interoperable metadata will allow us to search and combine these massive data sets more readily without moving them, as well as find what we need and ensure these different mappings are tracked so that we have it for reproducible science and for credit. So as we automate metadata and governance together and have it built into our system, we can move forward. Just 2 weeks ago, SOI convened the first of several workshops bringing together members from funding, publishing, data centers, academia, and industry. The workshop, entitled Credit Where Credit is Due, was to identify actionable, implementable solutions to how publishers, academics, and funders can recognize and reward the dissemination of acquired data and knowledge in ways that will result in career advancement, so beyond just publishing, such that the work of creating and sharing fair data is acknowledged for its massive value. Ensuring quality assurance at the point of collection is also necessary for us to correct problems faster in the field and make sure that the data we're collecting is of value. As we move to the future, we're looking to make sure that any solutions we create are open source and available to the community so that we can work together towards our problems. We're looking to add computational power to where the data sits so that we can enable more added value with artificial intelligence and machine learning. And we believe that cross-sector training is imperative for the future of ocean data and the blue economy. We've been considering how cross-sector training between computer science and ocean science can help set us up for the longer-term needs of oceanographic research. We partnered with the University of Chicago Data Science Institute, which trains the next generation of data scientists to provide access to real-world oceanographic data so we could work together on these problems. As data and technology grows, considering the cross-training is important towards the blue economy. Lastly, I just want to mention a few initiatives that we're involved in. SOI is a founding member of the Ocean Decade Alliance and partner with Ocean Decade. SOI is also part of the UN Ocean Decades Funders Collaborative and involved with a number of endorsed actions such as Seabed 2030. As a partner of Seabed 2030, we've contributed 800,000 square kilometers of bathymetric data to JEBCO. I also want to just briefly mention MBARI's recently funded program, Ocean Visions AI, a new project that aims to accelerate the processing of and access to ocean video and imagery to enable effective marine stewardship, as well as FathomNet, an open source image database with labeled ocean imagery. Ocean imagery is a huge area that is expanding and is ripe for work that we all need to do together. Some of our initiatives that, sorry. I think I'm done. So thank you all, and I look forward to your questions.
Awesome. Thank you, Karine. Next, we're going to go to me.
Hello, everyone. I hope you're having a great first day at Oceans. It's actually my first time ever attending this conference. Very exciting for me. So I'll be speaking about Blue Insight, which is Kongsberg's digital ocean platform. This is our cloud services remote access platform that is very much a new product and very exciting for us. We recognize that there are challenges in ocean observing for all of us to make the right decision, to make the right data available to the right people at the right time, to make whatever decisions that they need to make for their field operations or resource management or economic value decisions. We recognize that it is complicated to set up robust data paths from ocean sensors and vessels to the cloud for a number of reasons. We recognize that collaboration is difficult with siloed data and many proprietary formats. Getting people to be able to speak to the same data types is difficult. We recognize that analysis is often very manual and therefore very time-consuming and requires specialist skills. We'd like to support ways of getting away from that. And then we recognize that remote management of sensor payloads, edge software, edge nodes, machine learning models over the air can be very difficult and require high bandwidths. So our answer to that is Blue Insight. Blue Insight is designed to collect, visualize, contextualize, analyze, and distribute data. You can choose to use some or all of those capabilities when starting a project, and we offer key value to our ocean stakeholders. I think a lot of people in the room have the same stakeholders: aquaculture, fisheries, energy production, government authorities, and researchers and academics. All have requirements to get data off of different kinds of platforms, be it a buoy with an Iridium capability that can spit up a little bit of data once a day, once a month, whatever it is, versus these long-term offshore platforms that are generating lots of data and need to have a lot of interaction with them, such as offshore wind groups. So basically, we can work with any kind of bandwidth connection in some form or fashion is the goal. So our generic system overview of Blue Insight, each one of these blue squares is a module. We've defined modules for onboard work versus cloud work, with the goal of getting all of the data from platforms up into the cloud for collaborative work. So on board, we have our sensor fusion module. So that's the job of that, is to collect onboard data and make it cloud ready, building a giant, or perhaps not giant, MySQL database. from Kongsberg sensors, but also third-party sensors. We're trying very hard to be agnostic here so that we can work with whoever needs support, all feeding the MySQL database. And we can also take in data from into that main database. We can add data from ASVs or AUVs or pairs or combinations of ASVs and AUVs. So all of that data will go into Sensor Fusion, get packaged up, get made smaller if necessary, or send all of it up if you can, to the core module in the cloud. So that's our cloud framework. That's our main framework. It's very secure. For storage, it's efficient, and we have standard dashboards for just immediately visualizing what your data looks like to make sure everything looks like you would expect it to. So once you have your data in the core, you can go from there. You can do sensor remote. We're finding a lot of interest in this. So this is remote access for EK sonars and EM sonars that Kongsberg produces. We can show you all of your data. We can show you a little bit of your data, depending on what kind of bandwidth you have. We also have an Ocean View module. So this is web-based 2D and 3D visualizations that are highly customizable depending on what you're putting into them and what you would like to see. Very shareable with customers and clients. We also have an analytics module. So this is where we would be able to run customers' algorithms for machine learning and AI. We're not necessarily in the business of creating those algorithms, but we want to support you to be able to run them in the cloud most efficiently. And then finally, we have our data forwarder. So this is the module that will convert data to final formats to go to archives, global archives, whatever your archive of choice is. We will work with you to produce your final formats and automate the distribution to those archives. So I have time for 2 examples. We have a number of projects going on globally right now, but I tried to choose some kind of relevant ones for this group. So our glider project is with Akvaplaniva, which is a Norwegian research conglomerate group. The challenge that they have identified for us to support them in is to, 1, efficiently manage and collect data from a fleet of unmanned vessels or vehicles while providing services to their industrial and academic users. So they want to take the data off these unmanned platforms and then share the data with different kinds of users with maybe different kinds of security needs to keep the data private or share it. So the solutions are, the modules here are Core and Ocean View. So Ocean View is, again, that 2D, 3D flexible map-based solution. So we can see the fleet in real time, what it's doing. We can see historical data of, say, ice maps. We can see real-time traffic. So this is very much a vessel management solution, which we have a lot of experience with Kongsberg through our Vessel Insight program, which has been in place for a number of years. And then the second portion of their solution is to handle large and diverse data coming from these gliders. So we help them improve their data flow for indexing, cataloging, and staging their environmental data, and then sharing the functionalities. And then they're doing some data analysis in the cloud with our analytics. So our modules here are Core, Ocean View, Data Forwarder, and Analytics. So they're doing some processing work and automated QC on the data from the gliders, and then sending it to an external database for sharing, and that's all happening automatically. My second example here is, again, a Norwegian group, the Institute for Marine Research. Their challenge was to automate the detection and classification of biology on uncrewed platforms. So this is EK80 data to allow for efficient upscaling of ecosystem data collection. So to make decisions on the vehicle of where to go based on what they're seeing with onboard algorithms. So the solution here is enabling remote operation. So we can actually, the main platform can interact with it, but also classify on the platform through machine learning of that broadband echo center data to make decisions on the platform itself. And so the modules for that one are Sensor Fusion, Ocean View, Sensor Remote, Data Forwarder, and the Analytics. And so in summary, this is our offering, Blue Insight. It offers improved efficiency for streamlined data collection, automated analysis of large data sets. It offers better collaboration with partners and stakeholders by built-in user management for secure and efficient data sharing. So we very much recognize that when the data lands in the cloud, it is your data, and you need to be able to control who you would like to see it in the short term and the long term. So full ownership and control of data to support your decisions. And finally, it is an open ecosystem, so there's no vendor lock-in. We would like to be able to work through APIs and other third-party integration handshakes that can happen in advance. So we're working with other groups to see, can we work with you to get sort of ready in case somebody approaches us and would like to be able to run your software in our cloud. That's happening. And so that we can be usable across platforms, sensors, parameters, and marine applications. So I would just like to say that there's a team of experienced engineers behind this work who already have a lot of experience with the various flavors of ocean data. And we would like to hear from the community, is this a useful thing to you? What seems to rise to the top of those different modules? What would be most useful to you in your work? And what makes sense to have it be a provider providing it versus have it in-house or on-prem? That's it. Thank you.
Awesome. Thank you, Mimi. Next.
So I'm really enjoying getting to know this different audience. So I'm going to talk to you not today about a technology or a data set, but more about a pattern. And I think it's something that we need to consider as we're looking at building out this blue economy and doing it across different sectors and scales, right? Most of us in this room are scientists and engineers, right? Yes, yeah, okay. We all are, we gravitate towards the environment component of the blue economy, right? How do we sense that particular variable? How do we get, a better signal to noise ratio, right? But when we're starting to build out this blue economy concept, we really have to think beyond that. We have to start to integrate not just the environmental component, but also what that environmental component is going to impact as that blue economy is built, right? What is the social component, right? Who benefits? Who doesn't benefit? How do we have the data to integrate with that environmental data? What is the economic benefit? Is a port required, to actually get, your ships to sail or your goods to port? And so we need to find a way in which we can analyze all this together in a single way. And this is what we call in Esri the geographic approach, right? We're thinking about not just a pixel in its place, but where that pixel occurs and its relationships to other components. So this is kind of the pattern that I want to talk about, and how we can do that, right? So I'm not a GIS person, I fully admit that. I've really no background in it until I came over to Esri. And if you asked me 10 years ago what GIS was, I was like, well, it's a bunch of dots and lines on a map, right? And we all had those clunky interfaces that we would play with, and it was like, okay, it's that blue diamond, or it's the red diamond, or the green diamond, right? But it's advancing so rapidly right now. So, not only is it mapping the diamonds and the lines and the boxes, right? But it is sophisticated data science, machine learning and deep learning that you can do in the cloud. It is advanced visualization. It is awesome APIs that you can build and share your information with. Right? So it's not just me sitting at my desk anymore doing this thing because you're a GISP, right? You're a multidisciplinary scientist, or you're working with a team, but you're working within this ecosystem. And I think it's really allowing us to start to really advance the things that we need to be able to do to grow this economy. And one of the things that we're seeing emerge right now is this proliferation of portals. So you've used all that technology, right? You've built your data products, and maybe it is, you're collecting bathymetry, or you're doing some kind of in situ sampling in the coastal waters, right? But you're sharing that information, and you're not just sharing that information on an FTP site over here, or I have my own API, or you have some delivery service, but that we're working and publishing in a common way. And so that by definition, all of our information are raw data all the way to your derived products are interoperable. So I can be over here and I can just grab your stuff and mash it up with mine. And I can go over there and grab that economic information and mash it up with mine. And it's all going to work beautifully together. And it crosses disciplines, right? We need to start to think about this as how we are going to build out this capability globally to tackle different challenges. But what we're seeing is, so people are creating these portals and they're connecting them. And so we can start to build a I guess you could think of skins of these different versions of portals. I can take a little bit of yours and a little bit of yours, and I can build a new site and a new capability, right? Integrate that data together into derived products. We're seeing this being done commonly. We've been supporting the UNEP's coastal eutrophication projects with their sustainable development goals. We just, in a couple weeks, built an entire climate mapping and resilience portal for the US government based on this, because the government was already sharing data in this complementary way. And I think that's really awesome. You know, you don't need to take years to develop these initiatives and to really move the ball forward. One thing that we've been working on at Esri is building this collection of curated data, working with our partners in government, in academia, and private sector to really say, okay, you got great stuff. How do we get it more visible to the rest of the community, right? So here's open data and, again, information products that can jumpstart somebody's work. They don't need to spend a year prepping all of that information. They have that derived thing that they can just suck into their project and go with it, right? And so this is really also expediting the process of making, or of finding information that we need to be able to, again, support this blue economy. Now, when I used a couple of key words there. One was information products, and the other was jumpstart. So I wanted to give you a couple examples of how that can be done, right? So you started with that huge cloud of technology, and again, we're all engineers and scientists, so we love that technology concept. But you have to start to move into the products that people need to be able to use, right? So marine cadasters, coastal reporting tool is a really awesome example of this, right? So you go there, you get all the information you need about all those three concepts, about the environment, the economics, the social components. They're all summarized within the same areas, right? We've been working with the group on Earth observations to build a framework to understand and talk about ecosystems in the same way, our ecological coastal units and ecological marine units, which basically are an objective characterization of our ecosystems, so that you can look at apples and apples and use the same language to describe them, and then also understand how those apples are changing to oranges or bananas. And then you can apply that same methodology across the planet. One thing that we really love to do is take big data and get it down to small bits, right? You don't need that massive data store. You shouldn't really need to use it for most cases, right? You're trying to use the information that comes out of it. So how do we get that, really crush down those big data stores into more refined products? So instead of AIS data, which is a bunch of CSVs on some site, right? We're building that into actual lines on a map, right? That has information enriched in there, right? So now you could, quickly analyze in a couple seconds with dwell time on any of these ships. How do you do your marine spatial planning and optimize the location of different elements? That would be a first start, right? So you could do that little, analysis in a matter of minutes instead of taking days and weeks to do it. And then another example, again, would be we've been integrating satellite observations to characterize eutrophication in the coastal zones all across the planet. And then when you have enough of that information, you can start to look at trends in coastal eutrophication and how is that going to impact the functioning of the ecosystems there. So just a couple thoughts on how I like to approach thinking about tackling this challenge and thinking of holistically across the different disciplines. Thank you.
Excellent. Thank you, Dan. So now, last but certainly not least,
As he said, I am an uncrewed systems data manager working at NOAA's National Centers for Environmental Information. And because I know everyone's wondering, what does NCEI do? So we actually host and provide access to one of the largest environmental data archives on Earth. And that enables us to maximize the federal government's, and thus the taxpayers' billion-dollar investment in high-quality environmental data. And we also are able to place that data into temporal and spatial context. So when I say one of the largest, I'm sure you're wondering how much does that mean? Currently, we have over 44 petabytes of data in our archive, and this is also to showcase how much more data we're expecting, especially with the proliferation of all these uncrewed systems that everyone's talking about at this conference. So by the year 2030, we expect to have over 1,000 petabytes in our archive, and how we're able to handle that and turn that data into something actionable is something, I guess, the reason why I'm on this panel now. So we at NCEI don't necessarily work with real-time data, but we take that real-time and near real-time or delayed mode data to put it into context. So not only deal with the now, but also use it for predictive capabilities, for climate projections, as well as reconstructing the past for like paleoclimate reconstructions, anything like that. So we really do work across timescales. Another thing I wanted to point out is we do create a lot of products, and NOAA does a lot more than just oceans and weather. As someone who works for NOAA with the last name Weathers, I definitely get the connection people have between weather and NOAA all the time. But we do a lot more. We do fisheries, and one thing of note is NCI does host the World Magnetic Model, which is utilized in all of our cell phones for GPS. So NOAA also has the NOAA Open Data Dissemination, or the NOD, and that is our way of addressing the interoperability challenges. So NOAA takes a lot of data and a lot of data from different diverse sources, and we need to put that into context. So what we do is take data from wherever and whoever we can get it from. We then have to get it in a format that can be utilized, so we can use it in all these analyses. So that means transforming data formats. As multiple people mentioned, there's a lot of proprietary formats. We really try to push open source. And then we've been using the big three cloud providers: Google Cloud, Microsoft Azure, Amazon Web Services, AWS. And we can put data sets into the cloud, their clouds, and end users have the ability to download those data sets from the cloud provider of their choice. Data egress is free, so anybody can download it. We currently have, I think, over 200 data sets in there right now. More are always on the way. And then we're also, what are we doing right now, specifically in CEI? So we are working with the Navy on data interoperability. So this was an action through the C-Note Act, the Commercial Engagement Through Ocean Technology Act of 2018, that really pushed NOAA and the Navy to work together to make us have data interoperable in uncrewed systems. So currently I'm working with the Commander Naval Meteorology and Oceanography Command to create a metadata standard that's agnostic for sensor and platforms, specifically for uncrewed systems, that hopefully industry and academia can also adapt. So when you want to reuse someone's data set, you're able to without having to recreate it in the format of your choice. Okay.
So now we're going to move into the Q&A portion of our panel discussion here. So I'd like to invite everyone in the audience, as well as those joining us online, to go ahead and start formulating your questions to submit. If you're in the room, please queue up behind the microphone in the center there, and we can get to your questions. If you are online, I believe Jake is hoping to relay those to me to be able to ask the panelists. So while you're all formulating your questions and getting those submitted, or making your way to the microphone if you're eager, I'm going to go ahead and have an opening question that I'd like each of the panelists to answer. So I'm going to go ahead and read that. With more and more technologies entering the ocean space, how do we plan for the storage and processing of these increasing data volumes? And beyond just collecting and storing data, how do we effectively visualize, distribute, and promote access to these data to make them actionable for a blue economy? Let's see, let's start with Dan.
All right. Yeah, all right. I was supposed to think of this one ahead of time, but now I failed in my homework. But one thing that we like to do, and I kind of mentioned it, is think about not the data, but what are people most likely trying to get out of it. We like to think of it from a user perspective. If you can think of what the use case is, you can usually whittle down that big data into something much more manageable. And then the other thing that we do once we get it to that point is we say, all right, what is the structure of a web service that we would need to provide, and how would it be used? So does it need to provide visualization? Does it need to be analytical? What are the different workflows that it would need to support? And by doing that, you can really start to refine what that data product is and then minimize your footprint with your storage.
Awesome. Thank you, Dan. Colleen, would you care to weigh in?
I just want to mention that's like 7 questions, not 1. So just for the record.
Guilty as charged, sorry.
I think with regards to storage, I mean, the big question is on-prem versus cloud, and I think you have to really consider your business model. What is it you're trying to do with the data? Who needs to access it? For how long? In perpetuity or for some, period of time? Processing, I think we're going to need a much bigger workforce until automation really catches on. I know that it's very much on the way, in progress by a lot of really smart people, particularly in the mapping industry, but it's not going to really fully be here and for a few years yet. So as we're going to have so many more platforms in the next few years, we're going to be having exponentially more data and need people to be able to take a look at that because the data is only as good as it's interpreted.
Excellent point, excellent point. Kareem.
Sure, thank you. Hello. So I think for me, what I see in thinking about how we deal with this is that we need to address the fact that the massive increase in data storage needs is not specific to oceanography and ocean sciences. I mean, we have slightly different needs, but for the most part, this is happening pretty much in every field and industry. And we need to be cognizant that new technologies are going to be developed that we will need to utilize as they become available. And so, as it was mentioned by a few people, we need to be building our systems interoperably on standard practices so that we can utilize those systems as quickly as they come and be more agile than we've been in the past. And then just on the visualization piece very quickly, I think there's a lot of things happening in visualization, but especially as our data grows, we need to go back and think, what is the point? Like, visualizing for itself is cool, but we're trying to present information or show a report or answer a question, and sometimes, although in the past the answer has been to visualize it, it might not be in the future.
Thank you, yeah. Let's go to Mimi.
Thanks, Joel. So I'm going to repeat the question because it's been 3 answers since then, and it is a long one. With more and more technologies entering the ocean space, how do we plan for the storage and processing of rapidly increasing volumes of remotely collected data? It's a big question, right? So I jotted down a bunch of notes. I think organizations need to listen to and be prepared to catch and support our clients' data handling needs and create solutions. Maybe one of those solutions is actually making smaller files. I don't know if that's possible, but are our files very fluffy? And can they be like cotton candy that's gotten wet? Can they become smaller so they actually are much easier to manage? I don't know, but is that a question that we could ask the experts? Yes. We need to make cost-effective, efficient, and secure use of powerful cloud resources and make them accessible to people that don't necessarily know what they need. We need to make ease of use there for people. We need to ask the right questions to potential users so that we don't run into blockades later that's like, oh, I need 12 people to log into my cloud resource tomorrow. Like, but you needed to do a little bit of work. We needed to know that a little while ago. So we can ask those questions up front because we have the experience to do so. I think industry needs to work with each other to get resources cloud ready, like the APIs and the other handshakes that you can have ready to go, so that when people approach you to get into their clouds, to get into your cloud space, but with their needs, you are already like a little bit ready. So I think we need to have those conversations. I think we need to ensure stakeholder confidence in data security. I know that industry, versus government, there's very different in which part of the government, but very different requirements for keeping your data super private versus shareable to a few groups. There's a lot of different variability there, so making sure that people have confidence in that support. And I think we just need to really just make sure that ease of use is there. I think I did a cloud project when I was with NOAA. I see some NOAA colleagues in the room. It was really fun, it was really challenging, and it was like, I repeated my use case over and over and over again to people who were not marine scientists, and that was a big challenge. So if you're working with people who already are marine scientists, who have knowledge of this capability, I think the projects will go a lot faster and more efficient and smoother. So that's my answer.
Awesome. Thank you, Mimi. And Catherine, would you care to weigh in as well?
I didn't get the memo that we could have notes, so. Mine is probably a lot shorter. I think NOAA is tackling this in like a multi-pronged approach. So we're actively transitioning our data archive to the cloud now, as well as our processing power and capabilities. We're also investing quite a lot in R&D for new data management technologies that are utilizing like AI ML techniques.
No, that's a fantastic answer. And I'm hearing a lot of great themes in terms of data accessibility and discoverability, as well as assessing user needs, which I think is such important themes to be tapping on. I know that was a long doozy of a question, but you all had fantastic answers. And you're really hitting on the leveraging cutting edge technology and technologies like cloud computing and all these different machine learning techniques to be able to really create added value products. I noticed that in a lot of your opening statements, and it's fantastic to see this excitement coming from the government, coming from our private sector partners, as well as our foundation partners. So again, thank you all. There is one question that has come in online, but I see someone's at the microphone, so take it away from the microphone.
Hey, thank you very much. I'm only asking the question so Jake doesn't have to follow the iPad. He told me that was a requirement of this. So I'm Mike Smiskey with the Association for Uncrewed Vehicle Systems International. We were very big supporters of the CNO Act, Catherine, and we worked with Senator Wicker's office, and several of our members are in this room who also worked on that legislation. So I was just curious, kind of in the years since that legislation has been passed, can you give some real world examples of how that partnership between NOAA and the Navy has come to fruition? Because we reference that a lot when we're working with organizations like the Coast Guard, who's still lagging a little bit behind, and we are using that as an idea of how cross-government collaboration is impactful for accelerating the technology. So as a representative of industry, we'd love to hear a little bit more about that.
Great, well, I'll have a plug. You should come to me and Andy Evans from CENMOX talk on Thursday about our metadata standard that's come out of CNOTE. I think that's, it's on Thursday afternoon at 3. But for those who already have their flights made, I think the biggest thing, and it will sound like a joke, but it's not really, is that NOAA and the Navy are actually talking to each other. We're actively communicating our needs and how we can better work with each other. The case in point is the current metadata model that we have for the standards for uncrewed systems. We currently have an XML template available, and we are doing a pilot test right now with the National Ocean Service, which is a line office of NOAA. There's a lot more to CNOTE than just the data exchange standards, so there is also currently talks to see what kind of training opportunities can be made available. I believe there are some coming out with the University of Southern Mississippi, and just the fact that we are continuing collaboration, I think that's the number one thing. It's hard enough to talk intra-agency when you have a big government agency, in the Department of Commerce. Now multiply that by 10 with 2, Department of Defense and Department of Commerce.
Thanks.
So anyone else want to take a stab at answering it? Because honestly, the question online kind of builds upon it and says, what is the number one challenge or barrier in forming partnerships on data collection across industry? And so again, it dovetails very well in with the question this gentleman just asked. But does anyone else have any thoughts they'd like to share on, what's that challenge or what's that barrier? How can we maybe even break that down and getting partnerships around data collection and data access? Don't make me call on one of you. Mimi.
Partnerships around data access.
Exactly. Yeah. If there's any challenges or barriers that you found.
I mean, I think that you're always going to have a challenge of who has access to what software. So are there ways that we can kind of remove the barrier to software access by you don't need to buy a license for the whole year? Maybe if you just buy a subscription that's cloud enabled and it's just the portion of the software that you need in the cloud, and you can do that for 1 month or 2 months, then it becomes more accessible and it's rapidly available versus purchasing this lengthy 1-year software license, just as one example. But I do think moving towards things like NCDF and what's GeoJSON is one that you're using now, which are these are open source, but they're full. They still contain all of the information as the proprietary formats, but somehow magically they're shareable. I think moving towards more data types like that would be a move in a great direction. And I do think squishing data has to be a big thing. That chart that you just showed of, and 2030, that year was not chosen, by accident. That's the goal for global mapping, right? So that's one of the big drivers that I'm aware of is increasing that. So can we squish the data and make it less daunting? We assume that technology will always be able to keep up with data storage because historically it has, but are we going to reach a point where that's no longer possible? Maybe. Yeah.
Fantastic. Any other thoughts from the panelists? I won't call on you, sorry. That was really mean to me, Mimi, I'm sorry, but you had a great answer.
That's okay, I can handle it, Joel. I guess. My fellow first-timer.
All right, Karine, I see you have something to offer.
So I'll bring this from a very different point of view because I'm with a foundation and work a lot with academics. In terms of promoting access, and access can mean a lot of different things to data, but we even heard this morning in the plenary about collecting data by emailing professors and other people for data. That still happens, right? Because in academia, it takes a lot of work to make your data ready to make it accessible and share it. And part of and I mentioned this, we're trying to look into and think about is how do you shift in academia and the government for your career to make that step of making your data available worthwhile, both culturally so that we know that sharing has value, and then also what are all the steps? Like what do data centers need to do to help? And they do a lot of help with getting it into other systems, but what do publishers need to do? What do funders need to do? So that, the data as open data, when it can be open, is fair, is something exists, and then you can get it. And I think, so there's different steps, whether it's industry. And then in terms of partnerships, I think having bigger discussions, getting people in a room that don't normally talk to each other and just, again, explaining, some of these terminologies that we take for granted in ocean versus someone else so that we can start to get on the same page.
I think you make a fantastic point. I oftentimes think of partnerships as being between, private or public sectors or something like that, but partnerships can be interdisciplinary as well in terms of thinking about a data scientist working with an oceanographer to be able to really start to leverage these big data emerging technologies. So fantastic. I see we have another question. Go ahead.
Thank you. Richard Mills from Kongsberg Maritime. So I've spent 15 years working with autonomous uncrewed systems that generate an awful lot of data that gets used for a variety of things. Now, we're talking about distributing data for decision-making purposes and collecting it from all sorts of different sources, all sorts of different places, different organizations, individuals. So my question is multifaceted here. I apologize, it's a little bit of a lengthy one. Firstly, how do we trust the data that we get in? How do we prove the validity of that information? And then secondly, with the advent of automated processing, and I've already heard the terms that scare an awful lot of people, AI and machine learning, maybe there's a generational shift here, I don't know, but they can provide a little bit of an alarm bell to some people. How do we trust information that's generated, or how do we promote trust in information that's generated from automated processing?
It's a fantastic question. Mimi? You raised your mic first.
I'll take it first. So from my background in ocean mapping, how do you trust your data? You maintain your systems, you compare your new data to existing data if it exists, which is not always possible, especially if you're doing deep ocean exploration, for example. You calibrate your systems as often as necessary. You know what your system needs. Is it annual? Is it every time you launch it? I don't know, but you do that, you track it, you make sure all of your systems are calibrated so you can trust your new data coming in. How do you trust your algorithms output is a totally different question. But I think that there has to be some level of human interaction in the end, and there has to be a lot of technology testing going into these algorithms. You do the comparison of here's what the algorithm said, here's what 30 humans said, and we got the same answer. Our average answer became the same answer, I suppose would be more appropriate, but you learn to trust the algorithms because you have beat them so hard that they give you the right answer. And I think, personally, I would always want a human element on some level at the end of that AI or ML chain.
I'd also like to have Dan weigh in on this in terms of thinking about trust in data, and I'll try to repeat the question, and how we can do that. Especially, I'm curious because Esri, a lot of times you're providing access to different data from different portals. And so it's an interesting question in terms of how do you maintain that provenance? How do you make sure that the user who's getting these value-added products on these intuitive maps that can really help enable them to achieve their decision-making needs, how do you make sure that those are trustworthy and reliable?
Yeah, that's a big issue that we get a lot of questions on. And we try to partner and really establish really close relationships with authoritative providers. And that could be federal government, it could be, private sector. But it's not just you get this data feed coming from them, right? You have constant conversations about it. Oh, here's some improvements about it, right? So, we launched our own, machine learning, land classification on Sentinel that's real time, and yet there's a feedback process to it, right? Every machine learning and deep learning, it's going to need improvements, right? And so you have to have a way in which people can communicate to you what they're seeing in the data, if it's going to be automated and processed, and you have to have those opportunities to tweak that, and you have to be open about that process because no data that is remotely sensed is ever perfect, or that is derived from something is ever perfect. And so you have to go into it with that opinion or mindset, I think.
I completely understand. Coming from the NASA background, yes, there's reprocessings. Remotely sensed data is never going to be 100% right, but you try to at least have error bars or something on it that can help. And so, yeah, it sounds like Esri has a good approach to making sure that the data provenance is there. Catherine, would you like to weigh in with Noah's perspective? You knew the question was coming. You knew it was coming.
I'm not sure what else I can add. I just kept going back in my head to when I started talking to providers, data providers and data engineers, I realized that there's almost a disconnect between the two. So the scientists, they really want the scientific data from the glider, from the REMIS, from what have you. And then the engineers really want the vehicle health data to see what's going on. And I think what's been really beneficial with C-Note is you really need to keep those paired together. So what is the data being flagged because there was some battery failures, or was the sea state, what was the sea state like? So I think as I go through I keep saying the M word, the metadata, you realize there's a lot more that's behind the scenes that even the people that you think are discussing day to day might not necessarily be talking about. So I think we also need to bridge that gap. It might not be the exact answer that I was supposed to say, but.
No, it was terrific. Thank you so much. And I just don't want to overlook. Does anyone else want to comment on that question?
Yeah, I'll take a stab at that. As far as trusting the data, I was just going to say, bye Kongsberg. No, just kidding. No, but on that thread, what my focus is on is collecting good data in the first place, because the better your system performs, the less processing you have to do. So having people, looking at that data, verifying it throughout the course of the mission, making sure all the settings are correct, collecting good data in the first place is really going to lead you to good data at the end of the mission. So I put a bit more focus on that, but then I would just echo what Mimi said about having some, human interaction at some point, and feeding that process time and time again will build that trust over time.
No, and that's fantastic answers. Everything from making sure you have your instruments implemented correctly, to calibrated correctly, to taking the measurements correctly, following protocol, vetting it through all the different processing streams. It's all important to make sure we have that provenance and you can trust in the data.
I want to add something to what Colleen's saying about you need to make sure your data is good in the first place, collecting the best data that you can. So how do you do that on a remote platform? What are your pathways to making sure you can see your data on a remote platform to make sure it's good?
Top secret.
But that's the kind of industry partnership that we can offer, right? Behind these NDA agreements, we can work with you on your needs. We do work with them on their needs a lot to say, oh, you need to see geotiffs, you need to see super high-res stuff, you need to see it how often? Okay, what is your bandwidth? Okay, let's figure out a way that we can make that happen so that you're getting the best data that you can without having to log into your vehicle every 40 seconds or whatever. Sorry, I hope you guys could hear that. But yeah, really having these conversations about what are your actual needs? Like, what is your tangible question? Let's find a tangible answer, because I think the topics like ML and AI are so broad that you really need to just bring it down a little to an actual case and have those conversations.
Fantastic. It looks like Laura has a question for us. Go ahead, Laura.
Hi, all. So Laura Rogers from NASA. A question, we've been talking very kind of big data, but not huge, massive data. And I know there's a lot of initiatives out there for items like the digital twin, and actually just in the exhibit theater, they were talking about digital twins of coastal communities. But there's also initiatives out there for a digital twin of the ocean through the UN decade. So I'm curious, your thoughts on where you see some of the biggest gotchas, what's really gonna throw those initiatives off, what's really gonna be most difficult, and where you see some real benefit to that. Where can both academia and industry and government kind of play into that, and what are those roles going to be for each of those communities? Thanks.
It's a fantastic question. Who wants to go first? Karine.
I'll take a very first round stab so everyone else can think. I think I'm also in the metadata camp, and I think what we're going to see more of a need is to, and this actually gets back to the last question too, is this very strong metadata, not just so that we can follow the provenance, governance, and open science reproducibility of data, but so we can search and move and not move data so much and work across these hubs towards this huge data set that we can create these digital twins and have computational power next to the data in various places, and you cannot do that unless you have this larger amount of information and ways to track everything that has happened to that data. Because again, with a digital twin, you might be pulling one subset of data from some other portal that's actually been put together somewhere else and done something else, and it's combined with all these other things, and you have to be able to track all that. And so for me, I think we're talking about that and we're getting there, but we need to see that web and be able to track it and not have to move data into one location. And then I'll leave the rest of it for everyone else.
That's an excellent point. And you touched on data currency or flavors of data and making sure things are intercompatible. Does anyone want to kind of speak to that maybe? Because when you're thinking of a digital twin ocean, it matters that even though you might be trying to get at the same parameter, if there's a different flavor of it that you're measuring, it may not be exactly intercompatible. I see Catherine, you're nodding, Mimi as well. Do either one of you want to weigh in on that? Or Dan as he drops his mic? No.
So the digital twin concept is kind of a new one for me, but the amount of data required to create a digital twin of something, anything, but never mind the entire globe, it's unfathomable. So I never thought about having to actually have cross-platform sharing of data. It can't all be in one of the cloud platforms. So how do you get them to talk to each other? They read each other's metadata. Is that right?
I mean, I'm not building this myself, but there's ways to do that. I know that IODE in the UN decade is working on that, on some thoughts behind that, and more being able to, and I'm sorry if I'm saying it wrong, but inject some code into various portals so that they can search across and talk to each other in terms of seeing what data is available. How you computationally work across different platforms for the digital twin side is a whole other software question.
Yeah, I guess and figuring out ways to make all of these different data types that go into a digital twin become the one standard NetCDF or GeoJSON is, or maybe there's a series of 10 or something like that, but having everybody trying to output the same file type, format type, so that they can become part of this big system. I'd say that's going to be a big challenge.
I was going to say, everybody keeps throwing out the M word, right? And I think when we're thinking about digital twins, it's not just about the M word, right? We're talking about understanding all of these different types of data that need to be consumed into your digital twin that go beyond your realm of expertise. And it has to be human understandable, right? So, if you're at NASA, how many different ocean temperature products are there that are generated, or at CEI, right? Like dozens and hundreds, right? If I am not an oceanographer and understanding, but I need to incorporate that into my digital twin, how do I understand that? It's not going to be in the metadata. And I think we generally do a kind of poor job at really describing why a data or how a different data set should be used. What are its pros and what are its cons for different applications? Because they vary a lot.
Catherine, would you like to comment?
Yeah, I was also just thinking of the technical aspect as well that's difficult. I think we're kind of just, already in this discussion thinking the data's in the cloud. But first we have to also get a lot of this data from on-prem to the cloud, which in and of itself is fairly difficult. Even when you look at something like a lift and shift, I think in a lot of our minds it's like, oh, I'm just gonna take it here and just move it and boop, it's in the cloud. But even a simple lift and shift isn't that simple, right? You have to go to cloud native formats, like maybe you have to translate your NetCDF to ZAR and so other people can utilize it better. I think there's a lot of technical aspects that get glossed over in these kind of conversations that it is a lot more difficult, right? So everybody has Netflix and we can find the movie we want even if we're not looking for the title. But it took Netflix 7 years to get to the cloud. It took them a lot of resources to get optimized, and we're kind of just starting on this journey.
That's a fantastic point. And to me, I can't help but hear synergies with the previous question that was about partnerships in terms of can we work with people who have already figured this out? You bring up the fantastic example of Netflix, but thinking about how do we, again, partner with data science people who have already figured out, as Laura mentioned, big data. Big data is not necessarily a new concept. It might be a bit emerging for us in the oceans world, but there are experts out there with experience. And so you start to think about how can we leverage lessons they've learned or open source tools they've developed to help expedite some of these processes, because unfortunately climate change is not waiting. Does anyone else want to comment on that one? If not, I have another question from online. All right, so the online question, it's again talking about data. Due to the combination of data volumes and bandwidth needs, what is being done to make cloud storage and processing more accessible for remotely collected data? And I like to think of this too, not to hopefully change the intent of the question, but I also like to think of this in terms of how do we make data more accessible? The oceans are global oceans, and there are some people that do not have as fast of bandwidth or processing capabilities as we do in America or wherever country you hail from. And so I like to think through this in terms of how do we engage more of the world? How do we make this data accessible? And can we leverage cloud processing and storage more efficiently so that we're enabling new audiences to use the data? Again, I'm notorious for making one question into 7. Call me out, Colleen. Who wants to take this first?
I'll take a stab at it. I think one thing that, again, we like to think about the user case and the user perspective. So if we're building, these massive data stores, somebody hit it, right? Having a massive data store in the cloud of NetCDF files doesn't do you any good because it's really slow to open and close and read each NetCDF file. Until you actually try to do that, you're not going to realize that you're going to fail. So how do you build cloud storage, massive data cubes build your massive data cube, but if you can't actually read and subset that for your particular project, how are you going to get any value out of it? So you have to build the tools to work with the data along with the data structures themselves. And if you don't have both of them, it's going to be petabytes of data that are just sitting in AWS or Azure or Google, because it's still going to take you hours and days to run against that. You should have just downloaded it, right? So I think that's one of those challenges that we see this, put everything into the cloud, but if you're not thinking about the user perspective of how it's going to be used, you're just shooting yourself in the foot.
It's a fantastic point. Catherine, would you like to weigh in on this one?
Yeah, I was just thinking, I think that's where a lot of like microservices are going to come into play. And luckily, the cloud providers have already thought about a lot of this for us. You can see what data is being hit more frequently or less frequently. So you can kind of start moving things from, where you need to get it fast within, 15 minutes or 24 hours. And if some data is not being hit, very often, you can move it to Amazon Glacier, like you can move it to colder storage. And I think once we can optimize, like you said, in the cloud, but that's going to take a lot of work, that's where we're going to really see the power of, having our data in the cloud and accessible. And it, again, goes back to metadata. Like if your data is well documented and machine readable, you're going to have an easier time getting that data back out.
And I think you brought up an interesting point, which is the partnerships angle again, right? So as the federal programs are trying to put a lot of this data into the cloud, that they are partnering with the private sector or other user groups, communities out there to understand how it's actually being used. And if it is accessible, or what are the newest best practices and standards? Put on my old government hat, right? You're not necessarily up to speed with all the latest and greatest all the time, right? There could be something that's new out there that you're not really aware of. And so having that dialogue really can accelerate that process.
So in terms of data access, I think that we put a lot of focus on making the raw data available. And that can be really difficult, particularly with large data sets. I think one sort of format that we don't really talk about is underwater video. That's probably one of the largest data sets that most of us don't really know what to do with. But bathymetry is really not far behind that. And I think that we need to maybe shift our focus away from sharing the raw data as the priority and sharing the metadata as the priority, because you can share things like a polygon of the coverage instead of the actual raw data or GeoTIFF or other product, and that will help people just be aware that it exists. And then you have a mechanism to, say, inquire more about it, a link to get back to the company that collected it. But I think all too frequently we have a lot of folks in industry paying to collect data, and then some academic institution wants to also collect data, and then it just gets collected again because they just don't know it's there. So I think putting a focus in terms of data access on the existence of the data may be a quicker avenue to really make that known to folks that it is there.
I just want to add, I think it's been touched upon, but in terms of giving access and power to people that might traditionally not otherwise have it, I mean, we're seeing that in the cloud. Google, Amazon, you can open analysis tools, research tools, Jupyter notebooks and things next to the data. Data providers can make that and put that computational power there, so you're not downloading, you're not moving any data. And then you can subset, maybe get down, maybe you do want like a 10-line CSV of something, but you're doing it all in the cloud, and that makes it hugely accessible to students or people who wouldn't traditionally. They need to get on an internet, but they don't need, a huge high-powered device.
Any other thoughts on that question? If not, we are coming up on time. Oh, go ahead, Mimi.
I just want to build on that a little bit. For where I just came from at NOAA, data accessibility and fairness and enabling people who can't go to sea to still participate in oceanography was a huge thing. And I think what you're talking about, making cloud resources, powerful cloud resources, and good data accessible will open up that to scientists who can't sail for various reasons, they should still be allowed to be involved with ocean science. And I think that there's so much power in making your home laptop be able to do this powerful computing is invaluable for that reason.
Catherine.
Oh, sorry. I just wanted to add one more thing because I think we touched on one aspect of access, but I also wanted to touch on another aspect. We at NOAA try to make all of our data like 508 compliant as well, so that it is available for people who use screen readers or maybe need a high contrast when they're looking at documents. I think that's also something that we should be aware of in terms of access. Like, it's not just traditional, oh, where can I find the data, but can everyone actually utilize it?
It's all fantastic points. So we're going to do a really fast lightning round with the last question, and I just will go straight down the line. And they have no idea what I'm about to ask them, but I was going to say, so what emerging technology? What is really maybe the technology you're most excited about as we're moving into the future and thinking about big data in the blue economy?
Machine learning to do survey line planning for me.
AI on ASVs and AUVs to make their own decisions to like say, okay, I found the summit of that seamap. I'm going to take some pictures now.
I think I'm going to call out FathomNet and Ocean Vision's AI to really get us to a labeled data set for images and video to do all these things. That's really exciting.
I'm going to go with something that you mentioned, and that's like, Jupyter Notebooks, Python Notebooks. It is a universal language that we can all access, and it doesn't matter if you're at an oceans conference or a climate or weather or a terrestrial conference. It's a universal language, and it makes sharing both the data and the analysis that much easier.
Yeah, you took mine with automatic labeling, but I guess I'll switch it up and also say I would love to see just automated metadata creation, because so many people are scared of the M word that if they didn't have to do it, it would be much easier.
Awesome, fantastic answers. And you're not free to go just yet, but I do want to thank all of our panelists. This has been a fantastic discussion. Thank you all for being here. And thank all of those of you who are in the audience for also taking time out of your day to attend and for your thoughtful questions, both in the room and online. And before we do the round of applause, I think I'm going to invite Jake back to the stage, who may have a few closing comments to make.
Okay, so my closing remarks are, how about a round of applause for our great moderator and our panel? So just to close it out here, so this panel sparked out of something we did in Oceans 21. So if you have ideas for panel discussions for future Oceans Conference, please come see me, see Laura, see Ray. We'd love to hear your thoughts on this panel as well as some future panels. So I think we are approaching the exhibit hall break. It's not only a coffee break, I hear it's a beer break. So let's go ahead and adjourn. Thanks again for everyone for coming.